So basically, what is a core Hadoop? Core Hadoop is like, I'll just brief little bit before going into this topic. So core Hadoop means like, it's a storage system and as an analysis system. When we talk about storage system, how the Hadoop stores and what all the storage analysis, how it does is, when it comes to the storage system, you talk about HDFS, that is Hadoop Distributed File System, which gives the in and out information of the storage system of Hadoop and how efficiently it stores the data and retrieves the data from the system. And when it comes to analysis part, it is MapReduce Pro. I think I'm able to hear my voice. It's echoing. Someone is on the screen.
Yeah, it's echoing.
Yeah, thank you. So when I speak about analysis, it's all about MapReduce program, how efficiently I'm going to write a MapReduce program, so what it is going to do. So Hadoop mainly consists of storage and analysis. Storage of big data, analysis of big data. So let's get down to the storage part first. Like, it's very important to understand how Hadoop stores the data files. Hadoop stores the big data files and how it processes them, how you're going to retrieve them, what is the way it is going to store it, how different it stores the files from the other conventional systems which we have in the market now, and why it is giving that fast results even on the huge data sets. Before going to into the Hadoop architecture, we have three kind of files now. Basically, one is structured file, other one is a semi-structured file, and the other one is the unstructured file. Any idea about what is structured, semi-structured, and unstructured?
Structured means something like the data something in the normal data in normal database, like
yeah. Similar to your tables in a normal RDB, more structured. Yeah. In the same way, you have semi-structured and unstructured data also. When it comes to Hadoop, it deals very well with the unstructured data rather than the structured data. I mean, it is not that it is not going to handle the structured data. If it is able to handle the unstructured data, it is very well going to handle the structured data also. But when you want to see the Hadoop's effectiveness, like why it is so good, when you can see it only when it deals with the unstructured data. When it deals with the good structured data, there will be no difference between Hadoop and a normal RDBMS. So where is the difference coming is when it is going to deal with the unstructured data, how it is going to store, how it is going to process. Now let's get on to see, like, what is HDFS architecture. That is the Hadoop Distributed File Systems architecture. Sorry. Basically, Hadoop is composed of 5 daemon processes. One is called as a name node, the other one is secondary name node, the third one is the job tracker. These are also otherwise called as a master daemons. And then we have something called as slave daemons, that is called as a task tracker and a data node. So before going to the next slide, I'll just brief you what is this names all about. Name node is just like your server, which holds all the information. Secondary name node is like an mirror image to the name node, but not as an exact backup or a mirror. It just takes the logs and provides some kind of a support to the name node. Job tracker is actually the one which assigns the works, splits the job into multiple tasks and performs it. When it comes to the slave nodes, we have something called as task tracker in a data node. Task tracker is actually the one which performs the task. That is, once the job tracker has split the task, each task will be assigned to each individual task tracker, wherein task tracker performs the task. Data node is the place where your file is going to actually store. You can say data node is a comprisal of the storage system. So data node is the place where your exact file is going to store in. So this is something about the 5 daemons. The same thing I have written it over here, like what is name node. daemon stores and maintains HDFS metadata. Secondary name node performs housekeeping function for name node, like whether it is up or not, or the log files are there or not, whether I'm collecting or receiving them or sending them. Sorry. Those all kind of tasks the second name node takes place. Then the job tracker. So it is what it does is whatever the MR jobs or mapped is whatever the job which comes to the server, it is going to take place, which comes to the name node. The job tracker is going to take that job and split that one into multiple tasks, like distribute the individual task to machine running the task tracker. So wherever the task tracker is running, it is going to assign the job tracker. Job tracker is going to assign the task to that particular task tracker. So what is a data node? Data node is it stores the actual HDFS data block. So have you been told about anything called blocks and size? Nothing, right?
Block size?
Block.
No.
What is a block and what is it?
No.
Okay. As we move on, I'll say what is a data block and what is exactly that means. As you said, task tracker is responsible for instantaneing and maintaining individual map and reduce jobs. So because all the outputs collected from the reducer, the function is going to use that one. And then we have something called as edge node or a gateway node. So gate is access point for external applications, tools and users that need to utilize the Hadoop environment. Just like our firewall setup in front of a server, through which only you have to go, that is, with this occurs, this is only going to happen. But there it is a two-way communication. Once it sends, the server again sends back. But here it is just a one-way communication, like whether you can just load the data or you can cook up some data in the some other file and load the data. That is how you are going to deal with the, when that comes into picture, you have something called as a gateway. Instead of hitting the name node first, you will hit the gateway. This will be clear when I explain you the architecture diagram. I don't have it over here, but I'll be explaining about the HDFS architecture diagram. That will be clear when I explain about it. Like, for example, if you see this one, I have a client application. I want to access some files into the some files in Hadoop. So how I am going to do it? So there are two ways. Like one, you can set a gateway server before the name node, before the application actually hits the name node, or you can directly hit the name node. So that is the meaning of the edge node or a gateway node. So it routes the process to the name node if you place it, or else the application directly hits to the name node. So how the data is going to be stored in the HDFS file system? It is going to store data in the form of blocks. Each file is going to divide it into number of blocks, and all these blocks will be stored in the HDFS file system. That is a data node. Let's say that is a data node. So how it is going to store? There are certain things which it maintains when it is going to store a data block. So each data block it is going to replicate thrice, and then only it is going to go on the job. Why it is replication thrice? There are certain rules which I will be covering in the later part. Maybe not today or tomorrow. I will be definitely covering about that one. So this is how a file is stored. So far, any doubts or any clarifications required?
Yeah. What is daemon? Is that a daemon field, something like that, or?
It's just a service. You can just call it as a service.
Okay. So I mean, is it similar to the daemon source that we encountered in Java?
No, not that one. It's just like, instead of calling it as a service directly, they call it as a daemon.
Okay.
I could carry on.
Yeah, and what is the size of the data block? Or it's a...
Yeah. By default, it is going to be 64 MB, but we can always customize it.
Okay. So if you have got the 10 GB of data, then you will be dividing the 10 GB of the data into the 64 MB of
Yeah, by default 64 MB. We can also configure that one. So
yeah,
by
yeah,
default, whenever I send a file, like for example, when I send a 120 MB file to the Hadoop file system, and I have not configured any file size or block replications, so by default what it does is it takes default block size as 64 MB and the default replication factor as 3. So by default the replication factor in Hadoop is 3.
okay.
These are all the default, but as I said, you can customize. So when I say 120 MB file, it is going to split into two blocks, right? So each block is going to again have a multiple copy, like 3 copies of, let's say block 1, block 2, is each of size 64 MB, 64 MB, and then you have some file with something, and you got some records. When your replication factor is 3, what it does is it is going to replicate your block 1 into 3 parts. That is, you will have 3 copies of your block 1 and it is going to store all those 3 blocks in different locations. When the introduction was given, had this point has been covered, like Hadoop is an 100% fault tolerant system.
Little bit, but not that detail.
Okay. It has been touched, right, like Hadoop is a 100% fault tolerant system.
Yeah, that's what he said, but he doesn't. I mean, he didn't describe why or how.
Yeah, explanation.
Why in a sense, the explanation which I am giving you, the reason why Hadoop is 100% fault tolerant. So I am saying that each block is going to replicate it 3 times, right? So that means there will be 3 copies of same block, and those 3 copies will be stored in different locations. So whenever I want to retrieve a file from one place, I will see all the 3 possibilities and say which one is the maximum latest thing